Good everyone, my name is Graphics. If you look at the front of the screen, you will see a question, and the question says, determine the discharge through a trapezoidal notch, which is 1 meter wide at the top and 0.40 meter at the bottom and is 30 centimeter in height. The head of water on the notch is 20 centimeter. Assume coefficient of discharge for rectangular portion is 0.2, while for triangular portion is 0.60. So this is a section of a trapezoidal notch, right? So the data here given from the question says that the trapezoidal notch is 1 meter wide at the top, meaning the top width is 1 meter. And if you look at it, from M to S is what? 1 meter. Can you see that? Then we'll move forward. It says that and 0.40 meter at the bottom. So it means that the base width, which is the length of the width, is given to be what? 0.40 meter. So BC is the width, the bottom width of the trapezium. Now, we move further. It says at the bottom and is 30 centimeter in height. The height of the trapezium notch is given to be what? 30 centimeter. So if you convert 30 centimeter to meter, it will be 30 over 100, and that will be 0.3 meter. So it means that the height, that is from B to N and from C to P, is equals to what? The height, and that is 0.3 meter. Now move forward. It says the head of water on the notch is 20 centimeter. So the head of water, capital letter H here, is 20 centimeter. If I convert it to meter, I'll divide by 100, and that will give me 0.20 meter. That is the head. Then the coefficient of discharge for the triangular portion is given to be 0.6, while the coefficient of discharge for the rectangular section is given to be 0.62, as said in the question. So this is what we have here. So what you do here is this. If you look at, you say from triangle MNB. If I bring it out, this is what I have here. The angle is theta over 2, right? So the height, we know it is 0.3 meter. Now, since we are looking for MN, right? The question is, what is MN? MN is unknown, but you have it in mind that a trapezium is made up of two plane figure, a rectangle and a triangle. Now we know that BCNP is a rectangle, as you can see. And if I remove BCNP, I'll be left with MNB and PSC. If I bring them together, you can see that they are forming a triangle, right? So we have a triangle there. So we have two different shape here, a triangle and a rectangle. So if I want to get MS, I need to know MN. And once I know MN, automatically I have known PS. Are we good? So what is my MN? Now, since the top width is 1 meter, right? That is from M to S is 1 meter. Then if you look at N to P is equals to B to C here, which is 0.4. So if I subtract 0.4 from 1 meter, I'll be having 0.6. And since we have two right angle triangle here, which are the same, so if I now divide that 0.6 by 2, because we have two right angle triangle here, I'll be having 0.3. So it means that MN is 0.3 and PS is 0.3. So when I come here now, my MN is what? 0.3. So I'll see my tan theta from the word toa is given to be opposite over what? Adjacent. And the reason why I'm using tan is because of what? I have the adjacent and I also have the word the opposite. Are we good now? So my tan theta over 2 will now give me mn over 0.3. And we know mn is what? 0.3 also. And 0.3 divided by 0.3 is going to give us 1. So my tan theta over 2 is equals to what? 1. So we'll leave it that way. Now we move forward. Now the discharge through a trapezoidal notch is giving us the rectangular notch plus the triangular notch. Now have it in mind, the formula for rectangular notch is giving us 2 over 3 CD times length times root 2g times h raised to power 3 over 2, that is for rectangular notch, plus the triangular notch, plus the discharge of triangular notch, that will be 8 over 15 times CD times square root of 2g times tan theta over 2 times h raised to power 5 all over 2. So this is what we have. So from here, we start inputting our values. This will now be giving it 2 over 3 is given as 0.667 multiplied by the CD, which is the equation of discharge for rectangular notch, is given to be 0.62 multiplied by the length, which is given as the base width, and that is 0.4. Are we together? Because we're talking about rectangular here now, so we're talking about the length, the base width, this point here. So multiply by square root of 2 times gravity, which is 9.81, multiplied by the head, which is 0.2, raised to power what? 3 over 2, and 3 over 2 is given as 1.5, right? And 0.2 raised to power 1.5 is 0.089, while the square root of 2 times 9.81 is 19.62, and square root of 19.62 is going to give us what? 4.429. So this is what we have here. Plus the 8 over 15 is given as 0.533 multiplied by the equation of discharge for a triangular notch is 0.6 multiplied by the square root of 2 times 9.81 because of the 2g here, multiplied by tan theta over 2 is given as what? 1, multiplied by the head, which is 0.2 raised to power what? 5 over 2. Are we together? And 5 over 2 is 2.5. So 0.2 raised to power 2.5 is going to give us 0.0179. And the square root of 2 times 9.81 will give us 4.429. Right? So this is what we have here. So if I do the needful, I will now say my discharge Q will now be giving us 0.667 times 0.62 times 4 times 0.4 times we have 4.429 times 0.089, and that will give us 0.0652, plus we have 0.533 times 0.6 times 4.429 times 1 times 0.0179, and that will give us 0.0253, right? So when you add the two together, my discharge in a trapezoidal notch will now give us 0.0905 meter cube per seconds. So this is the discharge through a trapezoidal notch. So if you have found this video helpful, please don't forget to like the video, subscribe to the channel, and share the video. Thanks for watching.